Alright, in this video we will be looking at classifications of chemical reactions, the proper way to write a chemical reaction, and then how to balance chemical reactions using pictures. So the first thing I want to go into is what the different types of chemical reactions are. There are 5 different classifications of reactions that we are going to be learning about now. There are a few other ones out there, but these are the ones people generally get started with. The first reaction is called direct combination, and direct combination can be thought of as 2 different substances coming together and the atoms rearranging to make one substance. And again, it should be pointed out that chemical reactions really are just rearranging of atoms. So direct combination oftentimes is just 2 elements coming together to make a compound. It could be an element and a compound combining together, 2 compounds, although that would probably be fairly rare. For a decomposition reaction, you start out with 1 compound, and it's falling apart to make 2 or more different compounds or 2 or more different elements, or elements and compounds combined. So that's the second one, decomposition. The third one, single replacement, you can think of as one thing moving. So if you look at AX plus B, the X is with A, and then it moves over to B with B in the final part. A double replacement reaction is when you have switching of partners. So when we start, you have A partnered with X and B partnered with Y. And when you're done, you have A partnering with Y and B partnering with X. So the 2 things have switched positions. So again, single replacement, we have one thing moving over. In double replacement, I have 2 different things moving. Finally, with combustion, the combustion reaction is burning, and you're taking a hydrocarbon, which is something with C's and H's, like an unknown numbers of C's and H's, and there can be other things with those C and H's as well. You're reacting it with oxygen and making carbon dioxide and water. So we're going to be looking at a couple different examples of these reactions. We're going to be doing this in class also, where I will show you some different demonstrations, and we'll take down observations about how they look and what's happening with the reactions, and then looking at how do we turn that into a symbolic form. So we're really taking what we really see in life and turning it into observations before and after in words, finally putting that into a picture, and then the last step would be putting it into the most abstract version, which is the chemical reaction. So we're looking at all these different levels mean the same thing. So for the first one, we're going to be looking at the reaction of nitrogen triiodide, the decomposition. This is a very unstable compound. It's on the filter papers in the video here, and they're just going to tap it with a feather. And you see it makes a purple cloud. Okay, there's more to that video. You can certainly find that one on YouTube yourself and watch the rest, but kind of short on time here, so we got to make sure we get through. So before we have a reaction, we had a solid powder, and that became a purple gas. Okay, you were told that, or you are being told, that the purple powder we started with was the nitrogen triiodide. So using what we know from our bonding unit, we know that nitrogen triiodide, that purple powder, is Ni3. And then we can look at, well, what could nitrogen triiodide become? So what are some different possibilities? So nitrogen triiodide is Ni3, so N with 3 I's on it. So that's what we have before the reaction. We look at, well, what can that become after the reaction? Well, the only thing one compound can do is to fall apart in more than one thing. That purple gas you saw, if you know anything about halogens, is iodine. Iodine makes a purple gas, and iodine always comes in the form of I2. So it's tempting to say, oh, we make Ni and I2. There would be no evidence, like you'd have to kind of check for that. That's not what it becomes. It becomes elemental nitrogen and elemental iodine. Elemental nitrogen is N2, and so, but now we have this one iodine here that doesn't have a partner, so we need to give it a partner, because iodine always makes a diatomic I2 molecule. If we try to rearrange this back, we can't make Ni3 out of that. Okay, because now I'm missing 2 iodines here. But if I start with 2 Ni3s, I can then rearrange them to make an N2 and then 3 I2s. So that's what actually happens in our reaction. Because remember, the reactions were just rearranging atoms. So when we look at what is our balanced chemical reaction then, we started with Ni3, but we found that we need to have 2 parts Ni3 to start with, and we ended up making an N2 and 3 I2s. To be a little bit more specific, we started with Ni3 was a solid to start with. The N2 and the I2 were gases. To tie in our observations with this, the purple gas, the solid powder, okay? The classification of reaction, again, one thing falling apart, this is a decomposition. Okay? So moving right along. The next one we're going to look at sodium reacting with chlorine. So we'll go to find another video here.
Is heated until it melts and just begins to burn.
So there's sodium metal in that spoon. Starting as it's melted, so it's liquid, put in chlorine gas. The chlorine gas is green.
Burn in chlorine with an intense yellow flame.
We get a flame, and then after some time here,
exothermic reaction like sodium chloride. The glass spoon contains only white solid sodium
and then there's
chloride.
a white solid powder when you're done. Okay, so going back, before observations, we had a green gas. We had a white powder, or sorry, no, that was at the end. At the end, we had a white powder. We had a molten metal to start with. That was the sodium. Then looking at, what did we start with? We start with sodium metal, which we could just represent with an Na atom. Chlorine gas is Cl2. Then when I put them together as they react, the only thing that those two things can do is to somehow come together. And again, it's tempting to say, okay, they just came together. The problem is sodium metal likes to give up just one electron. Chlorine likes to take in one electron. So you can only take one chlorine atom for each sodium atom you have. So you need to start with another sodium atom to begin with. So again, we started with 2 sodium atoms and a chlorine gas. And we made sodium chloride, but we end up having to make it twice. Okay? So we needed, when we rearrange these, we have 2 of them. The class, tying the observations again, is the metal and the gas. The solid white powder, we can see. Classification of this, I'm just going to pin that out, is the synthesis or the direct combination. Either term is fine. On to the next one. Trying to move right along here. The next reaction, okay, see all sorts of interesting ones. Okay, burning magnesium and dry ice. So you can see that he's putting magnesium metal. Just going to mute that. He's going to light then the white solid is the dry ice, solid carbon dioxide, and he's going to light that on fire, and it glows. It burns very intently, so you can see like it's burning inside there. And again, if you want to see more of this, when you're all done, you've got, whoop, don't know what happened there. When you're all done, you see you've got this black powder, and so we can look at, well, what must be going on here? Okay. So again, we start with a silvery metal. That's the magnesium. We start with a white solid. That is the CO2. After, we have a black solid. I'm going to try to figure out what is that going to be. What is that black solid? So again, we start with magnesium metal. You can represent that with just a gray circle. start with carbon dioxide, CO2. We can look at what are some different possible ways that we can rearrange things to see this. Okay, so we could have the magnesium and the carbon switch places, but you can't just have that happen because magnesium will not combine with two oxygens, it will only combine with one. So maybe I make magnesium oxide and carbon monoxide. Magnesium oxide is a white powder and carbon monoxide is a colorless, odorless gas, so I can't be making that. If I bring in another magnesium atom, okay, I can make carbon and magnesium oxide. So carbon would be that black solid we saw. The magnesium oxide, I think I kind of skipped through the video, but I think there was a white powder on top of that black, or also like the smoke that was given off was a white powder, which could be the magnesium oxide. So again, when we write in our reactions, okay, we start with CO2 and 2 magnesiums. Okay, and we are making 2 magnesium oxides plus carbon. And again, I forgot to do this in the last one. We started with solid magnesium. We started with solid carbon dioxide. We made a solid magnesium oxide and a solid carbon. Okay, tying observations of that. Again, the silvery metal we saw, okay, this white solid we saw, the black solid we for sure saw, and I think sometimes you see a white solid mix in there also. Classification, you can think of this as the oxygen being displaced from the carbon to the magnesium. So this is a single displacement or single replacement, depending on which term you like better. All right, on to the next one. I've got 3 minutes left to try to get through the rest of these before I reach my 15-minute max. I don't know what you're trying to do, so stop doing it. Okay, then the next one, we've got a blue aqueous solution. Another colorless aqueous solution is added, and we make a rich blue solid inside.
That's not good.
So in this one, we have 2 solutions. I have a blue solution and a colorless solution. And I make a blue precipitate. Okay? And as we look at what is happening, the blue solution that it started with is copper sulfate. So CuSO4. The colorless solution is sodium hydroxide. What's happening is the sulfate goes with the sodium. The hydroxide goes with the copper. Problem is copper is 2+ and hydroxide is 1-. So I really need to have 2 of these, which means I had to have 2 sodiums to start with. Okay, but that's fine because sulfate is 2- and you need 2 sodiums with it in the first place. Okay, so again, the reaction, I have copper sulfate, that was in the aqueous stage, with sodium hydroxide, that was also aqueous, but I found I need to have 2 of those to make it balance out with my pictures. That makes copper hydroxide, copper 2 hydroxide, and, whoops, not that, sodium sulfate. Now, there was a blue solid made. I put the 2 on the wrong side of the parentheses here. I'm just better fix that. Just clean that all up. Get sloppy when I'm in a hurry. Now, we saw a blue solid made. Now, from experience, you will eventually learn that solids are made out of, that are blue. Blue things are often copper. So this one's still aqueous. Okay, and we'll look at why that is in the next video segment.